Hello and welcome to my YouTube channel. Friends, today we are going to learn about solid coding principle in C Sharp. Solid is a set of five design principles that promote well structured, maintainable, and flexible object oriented code. Using this principle, we can create .NET Core applications that are easier to understand, modify, and extend in the long run. Solid stands for single responsibility, open close, Liskov substitution, interface segregation, and dependency inversion principle. Let's talk about this one in detail here one by one. So the first one is single responsibility principle. According to this concept, a class should have one and only one region to change. This principle promotes well defined, focused classes that are easier to understand, maintain, and test, right? So let's say we have class that is doing so many business logic, and that is not a good practice. According to solid design principle, to to build a maintainable code, we should have small concise classes, right? Just one functionality, one business logic around them. So how to create those one? Simple, just break down large complex classes into smaller ones. Let's check that in our example code here. So I have a class called order processing, and in this class I have a method called place order. And here this place order is doing valid order validation, saving to database, and sending email confirmation. And each of these methods are like defined here in the same class. So this is very heavy lifting. We should not do that. So as per solid principle, how to do that? This one is example. So we are breaking a single class into three classes here. The first one is for order validation. The second one is to save into database, and the third one is for sending email notifications, email confirmation, right? So that's how like we break large complex classes into smaller ones, and that's all about the single responsibility principle. The next one is open closed principle. According to this principle, a class should be open for extension but closed for modifications. That means like we can add new functionality to a class without modifying it. And how can we do that? Simple. We should use technique like interfaces to define the contracts and then use them, extend them, and yeah. So let's check that in the example. So here we have a class having a method process payments. According to this principle, if we don't use that principle, then simple, let's say we want to process payment using PayPal today, right? And in future, we want to process the payment using Stripe. One simple way is like, okay, you overwrite, remove this code piece from here, and just write your new strike code here in the same method. So that's wrong practice. That is not good for code maintenance and other reason, right? Um, to create like to follow the open close principle, what we will do is create an interface called process payment, right? And now we can implement this extend this process payment functionality here. So let's say we want to do payment processing using PayPal, then we will do business logic in this class. And if you want to have stripe related business logic, then we will do in this class here, right? Similarly, if we want to add or use another payment processor, then we can follow. So that's how like we will do the code. So this way, like, we will not modify any existing code, but instead we will extend the functionality of the existing code. So very handy, easy, clean code. Let's talk about the next one. So the next one is Liskov substitution principle. And according to this principle, a superclass should be replaceable with object of its subclasses without altering the program correctness, right? So according to this principle, any class should be replaceable if it is being extended, right, by the child class. So let's check that in the code how to do that and what does that means. So here we have a class called user manager, and this is like virtual, this having two methods, login and access. Sorry, I just modified this one. So let's say we have access admin panel method, right? Two methods here, login and access admin panel for a user manager class. Now we want to extend a super admin class functionality using this parent class user manager. So, and the same class we are using for the member class and extending its functionality. So while the manager, so for super admin, this class is valid, and but for member it's not valid because super admin can access login and access admin panel, but member cannot, right? So here we override this method and throwing the exception. Now according to Liskov substitution method principle, it says like the object of parent class should be replaceable by the child class, right? So we have this user manager class, and we want to replace it with super admin class. So now we can easily do that, right? So until now it is not breaking any principle here. But if we want to do that for the member class, right, then here it will throw exception because member cannot access admin panel. And that's exactly all about Liskov substitution method or principle. So according to this principle, the member class should be always allowed to replace its method by the child one. So how to do that? So let's say we want to have access role based page, right? Now we can use and now we can implement here, right? Access role based page. So we know like it is a member role and it can access a particular page or not. Then now we can use both of these methods in super admin as well as member class. So that's all about Liskov substitution method. The next one is interface segregation principle. According to this principle, just like we did for class, breaking down complex classes into smaller one, we should use a defined interface accordingly, right? We should not mix up multiple business logic in single interface. Instead, we should use focused, smaller interfaces, and we should not even like over engineer as well, but should have a balance between like a particular balance here. So let's check that one in code. We have customer manager interface, and in this interface we have, you know, add customer, update customer, delete customer. So we are having like here database CRUD operation, and this is all about send customer report, some business logic, and this is email notification. So we have mixed up here like unrelated methods, right? So according to this principle, we should segregate the interfaces into multiple one. So let's say one here we have interface that is focused on the customer management. So just three methods here, and this for customer reporting, and this one is for customer communication. So that's all about this one, this principle. Let's check the next solid principle, dependency inversion. So this is to create loose coupling in our program, right? According to this principle, there should be a loose coupling between low level and high level module. uh, and we can do that using some abstraction using interfaces. So let's check that one in our code. So we have notification sender service, right? And we are using this service anywhere in the program. So we want to send notification using email and SMS, and we are creating object of those other classes here and using here send email notifications and SMS notification. So let's say we want to have push notification service here. Then if we go and add another class here, sorry, method here, then it will violate, solid principle of open close, right? We should not modify the class, instead we should extend the functionality. So we will use dependency injection and use the correct way. And also we will be creating loose coupling, not just apply like open close principle, but we should be doing a loose coupling using interface. So we create this interface notification service and implement and declare this method send, right? So now we can inject this as a dependency anywhere in the code and use the send method. And when we use or inject this dependency in the code, we do not care like its implementation, how it is doing, we do not care, right? The implementation will be here in another classes. So let's say we want to send using email service, then we will use this one. And if we want to send this one, using SMS, then we will use the SMS service and inject our dependency in program.cs accordingly, right? And notification service of type SMS service or type email service or type push notification service. So we will inject the dependency accordingly and use the functionality accordingly. But then we do not care for the implementation here. So that's all about dependency inversion principle. uh, I hope you liked the video. Please share and subscribe to my channel. Thanks for watching.